Hi guys, good evening everyone. Right, Mr. Kadir Muhyideen. Okay, and welcome to the physics practical series. Okay, I think quite a number of you probably taking the O levels this year, and I suppose most of you are taking pure physics. But this session will also help students doing combined science, physics. If you're doing combined science, physics and chem, or combined science, physics and bio, this session will also help. So, what are we going to discuss about is what are the things to look out for the physics practical, and we will go through some questions which kind of mirrors your O level paper. Okay, so that's what we are going to do. Now, just before we start, right, I think they have shared the link. Now, I hope most of you have actually referred to the link and printed out the question itself, right? There's a question. I'm going to share that first. Okay. Guys, please check whether you all have this, the O level practical series. This is the handout. So we will be going through this handout mostly. Okay. And the next 2 hours, we will be discussing how to answer the practice question 1, 2, and 3. And so all of you should have a copy of this. If you have printed out, that's the best. But if you have not, at least you can make sure you have the link to it and you can refer to this, okay? Okay, what we will do is first, let me share a PowerPoint slide. All right. For those of you who just joined, okay, this is the O-level physics practical strategy session. Okay, I'm teacher Kadir Muhyideen. And this session will also help students doing the combined science physics practical. Okay. Okay, guys, to make it uh, more interactive, I want you guys to also ask questions in the chat. Please ask questions in the chat, and then the kind of questions you ask will help everyone. Okay. Okay. First, let me ask you a question. Do you all know when the practical O-level practical exam is? The pure physics students, you can give me the date, and the combined science students, can you indicate the date in the chat, please? Do you all know the date? Do you all know the date for the? Let's see how prepared you are. Okay. By the way, they have shared the link. Okay, 30th September. 30th September is the prelim, is it? Okay, 30th September. I wouldn't know whether it's your school. 30th September. Uh okay. 8th October for combined science. That's right. 8th October. Yes, correct. 5th October. Yes, very good. 5th October for the physics one, pure physics. Right. So you need to know uh physics practical for those students doing pure physics, right? The practical paper is called paper 3, which is October 5th. Okay, and I think the chem practical is earlier. The chemistry physics, the chemistry pure physics chemistry is earlier. Now combined science is October 8th. Okay, combined science is October 8th. Now, whether you are whichever combination you do, whether it's physics chem, physics bio, or chem bio, is all on the same day, right? Okay, so it's important, right, guys? We when we are preparing, we need to know when these dates are. All right. See, why is important is the next couple of months, right? If you have not been exactly very serious about your practical sessions, I don't think you're going to get many of those before your prelim paper. If you do get a chance, make good use of it. And let's say if you're not really going back to the lab anymore, make sure at least when you're preparing for the prelim practical, pick up all the important, like the scenario. Because you see, when you go for the practical itself, that feeling is slightly different. Okay, and it's good to go through this entire uh prep, and it's like a mock preparation. The prelim is like a mock preparation. So once we go through that kind of mental preparation and going through the entire exercise of the prelim practical, it will actually kind of set ourselves for the actual O level, right? That's important. Okay, the format of paper for pure physics, right? Like what I say is the paper three, the duration is 1 hour 50 minutes. Okay, you should know that it carries total 40 marks, but the weight of it is the weightage of it is 20%. So it basically contributes to 20% of your O level score. Now, for combined science students, your practical is 1 hour 30 minutes. Okay, and that contributes to 15%. The practical contributes to 15% of the score. It contributes to 15% of your score. So the marks for that is 30. Now, so generally, right, what is being tested now for those doing pure, there is a planning component. There's a planning component. You all know there is design your own experiment. But generally, for all things that are tested is how you manipulate, like how do you set it up, how you set up the apparatus, you follow instructions, right? You follow instructions and take measurements, okay, and observation. And how do you present your data, whether it's the table, whether recording of table, or let's say for chemistry, okay, um, how you come up with what are the color changes. So how you do your recording of data, the raw data and observations. You write down what you observed. And finally, the analysis can actually be a graph itself, plotting a graph, okay, doing some calculations and things like that, and coming up with conclusion, right? So, guys, we all know, right? The experiment itself, what is it actually testing? It's only testing this skill essentially. How do we follow a sequence of instructions? We follow a sequence of instructions, okay, and basically, how do you set up the apparatus? How do you make and record observations? And what do we interpret from the observations or results? Like when you plot a graph, what do you, how do you interpret the graph? Okay, like of course, you also maybe calculate the gradient and all those things, right? I'm talking specifically for physics, but this can apply to chemistry or bio. Okay. Now, of course, planning and investigation, like what I said, mainly refers to those students doing pure physics. Okay, there is a part where you actually design an experiment based on they may actually have even given you that setup. Normally what they do is they give you a question itself with the diagram and all, but they ask you to design an experiment based on certain like conditions, like you need to vary certain variable. And how do you do that? And evaluation, right? Of course, right? A few marks goes to like what are the possible errors or limitations of the experiment. Okay, and what are the improvements you could suggest. Now, to even do that, right, you must go through a few, when you prepare for it, right, you do different types of experiments. You go through like whether it's a mechanics experiment, whether it's a light-based experiment, electricity-based experiment. When you go through a few samples, right, you get some idea. But essentially, what it boils down to is the experiment itself. You will be able to figure out, you have to answer question number 6, right, based on the experiment itself that you are doing. Okay, so guys, how does the paper format look like? So, like for pure physics, right, there's a section A and a section B. Now, generally, what happens is you are allowed to use the apparatus for section A for 55 minutes, okay, and for section B, 55 minutes. Now, what can happen is this: you may actually start with section A and another student will do section B, or either way lah. And then after 55 minutes, you will swap tables. That means you cannot use the apparatus for section A or section B after that. So you have to do everything related to section A in that 55 minutes. Now, why do I say 55 minutes? Because the entire paper is 1 hour, 50 minutes. Okay. Now, section A has two questions. Okay. It has two questions. Okay. And it's 10 marks each. Okay. And one of the question in section A has the planning or design and experiment. Now, the section B, right, has one long question which is worth 20 marks. And this is the question that includes your tabulation and graph plotting. Okay, this will include tabulation and graph plotting. So basically, guys, section A, 20 marks, section B, 20 marks. Now, for those students doing combined science, right? Okay, students doing combined science. Okay, you can see this. Okay, sorry, 30 September is for chemistry. Yes, yes, correct. You are right. 30 September is for chemistry. So yeah, that's an important date, right, for chemistry. Now, guys, tabulation basically means, what is tabulation? Tabulation basically means drawing the table to record all your raw data. Like for example, if you change the length, so later we'll show you the table, coming up with a table, okay, where you record your data. L stroke cm, then maybe measurement of time. So how you record it using a table, that's tabulation. So for combined science students, you have 45 minutes to do the physics experiment and 45 minutes to do the chemistry experiment. Okay, and for physics, mostly I put there one or two questions, but most of the time it's just one question, and that will include coming up with a table and plotting a graph. Okay. And remember, when you do it, right, record all your observations as soon as you obtain it, right? Okay, so guys, very quickly, what are the things that you'll be required to do? You see, a lot of your experiments will be mechanics based. I can't just say that as a confirm will come, but a lot of times they will ask one mechanics based question. Okay, and things like measurement of length using a meter rule. Okay, that is common. And then measurement of time using stopwatch. Okay, the simplest thing that you can think of is the measuring the period of a pendulum, right? Using stopwatch. So remember, recording using the correct apparatus and recording to the correct number of decimal place. Now, temperature using thermometer, all these, right? And if you're going to measure mass, you use the digital balance provided. And if you're going to measure volume, you use the measuring cylinder. Okay. And who knows, they can even give you an experiment to do principle of moments balancing, right? Okay, it can come out. And if it's a light-based experiment, you can be given, okay, so don't think that they cannot give you light-based experiment. They can give you a glass block, they can give you a prism, they can give you a thin converging lens. It has come out before, okay? And they can even ask you something based on thermal physics. So everything is possible. Now, the other experiment that very likely comes out, right, or most likely comes out is an electricity based. Okay, so you can more or less confirm something like there will be one mechanics based and one electricity based. These are, it comes out almost every year. So for electricity, right, making use of your analog meters, right, diameter and voltmeter to measure current and voltage, and okay, and then maybe with all these readings to measure the resistance. Okay. All right, guys, I will not touch on the graph plotting now. Okay, I will ask there's teacher Benjamin here. Later he will go through the paper. All right. Okay. All right. So guys, let's come back. Okay. I repeat, for students who have not downloaded this or printed this, the link was shared right at the start of this in the chat. Okay. And it was shared much earlier. All of you should have printed this. But if you have not printed this, at least you refer to this and take note of it. Okay, so this we are going to go through this and go through sample questions, which is to mimic your actual paper. All right, so guys, remember one important skill, right? Or I would say very important is that, yeah, thank you. They have just shared it again. Okay, they shared it again. So anyone who does not have it, you can download the link there, right? So remember, guys, when it comes to practical, right, you must read the whole question, get an idea of what the experiment is all about. Okay, at least get a brief idea on what it is. And also look at the diagram. Okay, always look at the diagram. From the diagram, you also the setup. They give you some students, right? Um, Under exam stress, they try to like skip through these sections. They think that, oh, they are trying to save time and all that. So guys, now important, right, is it's actually, it will save you a lot more time when you actually read the questions carefully and look at the diagram carefully so that you know exactly what they want you to do. And then you set up the experiment, okay, using the parameters provided, and you follow the instructions, and then you record observations and all that. Okay. Now remember, normally the very first experiment, or in section A, I told you there are two experiments, right? 10 marks each. So it'll be like, the first question may be just to test you like how you record. Okay, it's like tested everywhere, how you record, whether you record the raw data to the correct decimal place. Now you notice, right? Here I put there decimal place, SF. Now decimal place is for the raw data, whatever you measured. This is for measured values, and SF is for the any calculated values, anything that you use your calculator and do, right? Then it will be the SF. And of course, make sure you get all the units right. Don't forget, guys, if you miss out the units, you keep losing marks for it. It's not like your your main paper. You make decimal SF error, you only lose 1 mark for the whole paper. But here, practical, right? Every time you make SF, decimal place, or units error, you will keep losing marks. So all this is important. If you go and take a look at your own practical, right? You see, out of 40 marks, if you have done the whole paper, you'll find that the reason why you only get 20 something is because you could have actually continuously made mistakes on decimal place and SF and units. Okay. All right, everyone, let's take a look at this. So it says, in this experiment, you will be measuring the time taken for a wooden cylinder. to roll down a 100 cm long ramp. So guys, look at this. This is a kind of a easy setup actually. So what they do is they actually have some sort here's a retort stand, and they actually set like a clamp or a raised bar, and then they actually put some plank here. There's a plank here or a ramp, and this ramp is about 100 cm long. Okay, it's about 100 cm long. And what they're doing is they have markings on it at the 90 cm mark, 75 cm mark, 60 cm, 45 cm, 30 cm. And the whole idea is you're going to put a wooden cylinder on the plank, and from the 90 cm mark, you are going to release it, right? This is what the thing is. So first, they said, look at this height hitch. They said set up the apparatus. So if it was you, right, you will be setting this up. Okay, you will be setting this up, and then you will adjust the value of H such that it's approximately 5 cm from the ground. Approximately 5 cm from the ground. Okay, so they already said set it up at 5 cm from the ground. So you have to be careful about this information. Now, so look at the first part, guys. Measure and record H. Now, let's say you are recording H, right? Let's say you really set it up to 5 cm. You set it up to exactly 5 cm. So you record it like that. H 5. Okay, so what are you expected to do? Guys, you cannot write. Okay, if I write like this, right, you are not going to get any marks. If you write like this, you're going to lose this 1 mark. So remember, you have to put the decimal place. Why 1 decimal place? Why 1 decimal place, guys? Because the precision of a ruler is 1 decimal place. Okay, I repeat, the precision of ruler is 1 decimal place. Now, one more thing, if you just put 5, also you're not going to get the marks because you forgot the unit. Okay, if you forgot the unit, you're not going to get the mark. Okay, now part D says measure and record the radius of the wooden cylinder. Radius of the wooden cylinder using a digital vernier. Now, look at that. Look at this, guys. 2 marks for this. Okay, why is this 2 marks? You have to ask. Okay, can you all put a circle around this? Okay, they want you to record, measure and record the radius of the wooden cylinder. Okay, using the digital vernier provided. So imagine there's a vernier, digital vernier. You're going to measure the diameter. Of course, you cannot directly measure the radius. You have to measure diameter. But why is it given 2 marks? Okay. So this is where I just want to highlight to you. Okay. This is the sample answer. Okay, guys, look at that. Okay. The point is what you are expected to do is at least take 2 readings of the diameter. You must at least take 2 readings. Okay, so this is a point that I want to highlight to you. Why is this given 2 marks? Is because if you just take 1 reading and you divide by 2 and give, you're only going to get 1 mark. Okay, but what you're expected to do is maybe there are slight variations in the radius. So guys, this always happens. Students only just take 1 reading in this case, and they don't know till now. Quite a number of you don't know why you keep losing this 1 mark because you never take diameter along the length. You should take at least 2 or 3 readings. So look at that. These are the 3 readings taken, and then you show the calculation for the average. You calculate the average, and then you divide by 2. Then you record down the radius. Now you note, right? The radius was actually given back to the original number of the, this is This is the precision. This is the precision of the. This is recorded to the precision of digital calipers. This is the precision of the digital vernier calipers. Okay. Okay. So finally, when you calculate the radius, you record it like that. Guys, do you all follow what I'm saying? All of you follow what I'm saying? Okay, yeah. So there's a question. Uh, I thought you only need to find average readings if they ask to find an accurate reading. Now, not necessarily because you are supposed to, like, that's what I'm trying to highlight. In this case, right, you are expected to know that you are supposed to measure something accurate. You are supposed to get something accurate here. So that's the reason, because they don't tell you that you have to take two readings or three readings and find an average. Okay. And if you go and look at your own practical, right, when they gave you 2 marks, and the reason why you only got 1 mark is because uh, you did not take the two or three readings. Yes, there is a link to the teachers, and okay, there's a link. There's only a link to the student's copy. Okay, if your question is there a link to the student copy? I think they put it right on top of the chat. Okay, okay, okay. Somebody asked about the SF here, right? Okay, if you notice this reading, right? Okay, a lot of us will think that this is actually uh 3SF, but you see, the one in this case, because the one keeps repeating itself, this can be seen as a 2SF or 3SF. Now, the reason in this case why this is given back to this 2DP, right, or 2SF is because I'm following the position of the digital calipers. Okay, digital caliper is not 0.01 mm. Digital caliper, the precision is 0.01 cm. Okay, 0.01 cm. Yeah. The micrometer screw gauge, right? Then 0.01 mm. Okay, guys, so the point is I want you to take note is the radius. In this case, the reason why it's 2 marks is because you're expected to do the average. Yeah. Okay. Place the wooden cylinder at the 90 cm mark of the ram such that it's parallel to the top edge of the ram. Release the cylinder and check that it rolls down all the way. Okay, rolls down all the way. Okay, and to the end. Why rolls down all the way? Uh, so that you don't stop, you don't go and check. It's like sometimes it you put it right, it may actually go off the plank. It may go off the plank. Okay, hold on. There's some Q&A. Must I include units in my working? I think you only need to show unit finally. Yeah. Okay, there's a question. Do I need to show units in my working? You can just show the unit at the final answer. Okay. So to be safe, we need to take average reading. Yes, yes, yes. Because you see, that's why I'm trying to highlight to you. You look at the marks given there. Okay, the marks given there is 2, right? So this is why a lot of you don't know. They are expecting you to show the average reading. Hi, when do I know what's the right position? Okay, good. When do you know it's the right position? Okay, like for example, right, meter rule, the precision is to 0.1 cm. Okay, vernier caliper is 0.01 cm. Like later we look at it, thermometer is to zero point 0 or zero point 0.5 degrees Celsius. Later I'll ask you all. Okay, for stopwatch, right? Later we are going to look at it. And then some of you are going to tell me what your school follows. Okay, we're going to find out. So that's important now. What is the correct precision to use? When calculating, shouldn't be round off to, yes. Okay, yeah, that's what I was trying to highlight here. Because when you calculate to 3SF, right? Okay, part of the reason why this was not given to 3SF but to 2SF is because technically the value here, you may think this is 3SF, but the one actually is repeating, so it can be seen as a 2SF. Besides, I'm following the precision of the instrument. But later on, right, we will see the next question where we actually do the raw data. How do you look at SF? Okay. Okay, place the wooden cylinder at the 90 cm mark and release it. Start the stopwatch and at the same time stop it when the cylinder hits the bench at point B. So guys, basically what you're going to do is you're going to roll it down from the 90 cm mark. It rolls down all the way to the end and you start your stopwatch here and you stop it when it comes here. Okay, and that's it. Record the time T1 and repeat to get 2 more readings of time. Repeat the steps 2 and 3 to obtain 4 more sets of readings for other distance. Okay, and complete the table. Guys, what I want you to do is, of course, you will not have the readings. Okay, the readings is not so important, but can you try to fill up the table, please? Can you try to fill up this table? Try to fill up this, yeah. Try to fill up the units here, the unit here, the unit here. This is the average, T average. This T is actually your T average. Okay, and then calculate. Can you all do this? From here, we can discuss, we can take calculation, we can do the, this is your raw data. Guys, everyone, can you fill up this table? From here, we can discuss. Now, just now, somebody asked what is tabulation, right? This is what tabulation is. This is tabulation. Okay, for those asking questions, right? Okay, so record the correct unit. And what is the height, guys? This is actually, okay, sorry, this should not be H. Okay, this one is wrong. Guys, can you change this? Wait, yeah, H is confusing here. This is not H. This should be the length. This is the length. Okay, guys, can you please change it? The length, this is the length. And this, let me show you the first value here, 90. Do I record it as 90? No, 90.0. Okay, so look at the setting there. This one should be L, not H. 90. And what is the variation that we are doing? We are varying 75, 60, 45, 30. Okay, guys, let me give you about 2 minutes to complete this table and then we discuss. So we only take average for measurement when it's not. We only take average for measurements. Yeah. Okay. So you see, if it's not 1 mark, yeah, at least you can still do 1 reading. But logically, you will know lah. Yeah, the 2 marks basically is a hint for you to go and take average. So it's something for you to take note of. Why is that? Now, this is just the T. This T is actually I already told you. This is the T means the T average. Okay, T in this case is your T average. It's just a symbol. Yeah, you're right. Generally, we use T for period, correct? Okay, but in this case, I'm just using T as a symbol for T average. Okay, so The capital T here is actually T average, not the nothing to do with the period. Yeah, this is not the period. Yeah. Uh, where is T2? This is T squared. Okay, so this is not T2, but this is square of the value. T squared. Okay, T squared. You're squaring the value. Okay, it's just to teach you how to record to the correct number of, this one is the raw data. Can you see it's all recorded to the correct number of decimal place? Now, can I just check with you all, your school, right? Do they ask you to record time to one decimal place or two decimal place? Guys, can you tell me in the chat? There are so many of you, just to get an idea, especially for stopwatch, for the pendulum, right? Do you all record to 2 SF or, sorry, 2 DP or 1 DP? Okay. Now that's the thing. A lot of schools will say two decimal place, but some schools will say one decimal place. Okay. Now, okay, you can follow what your school suggests. You should follow what your school suggests. Now, but for this particular reading, right? This particular reading, because the time involved is very short, because we are talking about very short timing, because the thing rolls down very quickly. Why it's recorded to 2 DP is simply because the time, you look at that, the timing involved is very short. If not, all your readings will be 2.7, 2.8, 2.8, 2.9, 2.5. You round up, right? 2.5, 2.3, 2.5. So it'll be like, you know what I mean? It will be too, not so accurate in that sense, because this is already not going to be very accurate because the time involved is short. But when it comes to pendulum, right, you just follow what your school has been teaching you, which is to record to two decimal place or one decimal place. You just follow what your school taught you. Okay, I just want to highlight in case you're wondering. Okay, guys, I'm going to show you the table now. Okay, if you have followed this correctly, right, your table should look like this. Okay, okay, this one is the X or L. So sorry, just now it's not H, the table there. It should be X or L. So look at that. 90, 75.0, 60.0, 45.0, 30.0. Just a minute, guys. Take a look at the table. Okay, so guys, look at that. Okay, so why do we need to square the time? No, because it's just a requirement of the question lah. It's just probably not stated in the question there, but the question probably wanted you to square the time just to see how you process it. Okay, one of the requirement is, so it's not exactly, it's just to test how you process it. So look at that. When you calculate the average, right? When you calculate average, you can get any value, right? But why do I keep it all to 2 DP, or in this sense, I follow 3 SF here? Because I follow exactly the SF of the time here. And then the T squared, right? Again, I process the value of t. I get I get three. I put it to 3SF. So the t squared is all given to 3SF. Okay, all the values are given to 3SF. So these are processed values. These are processed values, and the processed values are given to, especially this table here, this column here is 3SF. This is 3SF. Okay, this is 3SF. And you can think of the the average value, right? The average value, you can take it as it must follow the same DP as the raw data. Okay, even though you can also follow SF, but the average value, uh, we we try to give it to the same DP as the raw data, because technically it's an average value of the raw data itself. Okay, but t squared definitely is a calculated value. T squared is definitely a process value, so you follow SF. Now, okay, so that is the table. That's just to highlight something on the table. Okay, let me see if there are any questions. So wait, let me see. Why is there T in the table? Isn't T the period? Okay, so T in this case is the average lah. When we square the values like in the table, is it the same DP? Okay, so the question is, when you square the values, you must follow the SF. It is not the DP, it is the SF. Okay, is it acceptable to use meters? Yeah, you can record to meters. If you're going to record to meters now, you have to be careful. If you're going to record in meters, then the decimal place becomes like that, you see. 0 point, it is going to be like that. If it's 10 cm, it will be 0.1000. So if it's 90 cm, it will be 0.900. So somebody asks, if I record it to meters, what happens? So it becomes 0.900. So correct decimal place. Then this one will be 0.750. Okay, so that if your question is, if you're going to record it to meters, then becomes like that. Okay. Now, let me emphasize the question again. Okay, the reason why the t squared here is just to highlight that important question. Am I recording it to the same DP? No, I must follow SF here. Okay, because the original values are all 3SF, I calculate it to 3SF also. This one is 3SF. Okay, now so it's actually to teach you that these values here follow DP. This one all follow DP according to the precision of instrument. Like this one also follows DP according to the precision of the instrument. Okay, this is the ruler, this is the meter rule, this is the stopwatch. But this is following SF because this is a process value. All right. Okay, guys, identify one source of error in this experiment and suggest one improvement. Now, if you go back to this, right? If you go back to this, right? If you go back to this, like what I said, you can be practicing all these errors, but you really have to think about the experiment that you are doing. Like you look at the values that you got. Look at the readings here. First of all, look at the timing. These are really very short timings. These are very short timings. Okay, you can see that the chances of that being inaccurate or making some error is high, because you're talking about recording something for almost 2 seconds, or 2 seconds to 3 seconds. So it's a very short time. Okay, so the chances of having human, because you release it and it's going to, like, you start the stopwatch, and then when you stop it, there's going to be in terms of human reaction time, our human reaction time is about 0.1 to 0.2 seconds. So when you're talking recording over a short time duration, the chance of it being high is more significant, right? So that one is, this is what I mean by thinking about the experiment and writing. So this is a possible error. There's an error in timing due to human reaction as the cylinder rolls quickly down the ramp. And since the timing involved is very short, this is likely to be inaccurate. Okay, there is a high chance that the timing can be inaccurate due to human reaction time, as it takes a short period for the cylinder to roll down the ramp. Okay, roll down the ramp. So that is chances of it being inaccurate. Yeah. So how can you improve, guys? Can you tell me? Can you give me suggestions? Can you give me suggestions, please? How can you? How do you think we can improve this? Can tell me in the chat, guys. How do you think you can improve this? How can you make this error? Make improvements for this. Okay, you see, you repeat multiple times. Yes. Okay, but let's say for example, you talk about pendulum reading. You see, you repeat multiple times also. The time that you're talking about is still very short. You see, okay, okay. You take multiple times. You're talking about short duration, so the chances of human reaction being there is still significant. So what you could suggest as a difference to this experiment is, hold on, I see. Add a sensor at the end recording the time. Okay, that's good. Add a sensor. Yes, that's a good suggestion. Instead of manually recording it, you use sensor to detect when it leaves and when it ends. Yeah, that's good. Okay, someone said my school. Okay, video recording. Okay, that sounds all. These are all good suggestions. Okay, that's these are all good suggestions. Data logger. Yes, correct. Mm, okay, my school does not consider human as an inevitable error. Okay, so zero errors they consider. Okay, yeah, correct. Yeah, you can have a laser kind of things. Yeah, so you all are thinking in terms of using the technology, right? Where involves less of the human thing, more of technology, correct? Okay, so here I've just given okay, your suggestions are all good, okay, and valid. So I just said here, if you go by the same, using the same apparatus, is you could actually do the experiment using a longer length of the ram, such that the cylinder rolls a longer distance. Okay, or you could actually repeat this experiment with instead of using 5 cm, you could actually repeat the same experiment with keeping h smaller, because the smaller it is, then it's going to roll much slower, right? And then the time, overall time will be increased. So you could suggest a slight modification to the, like either using a longer plank and overtaking measurements over longer distances, or reducing the hitch, okay, such that it will take longer to come down. But I think quite a number of your suggestions are valid, in the sense that instead of using human to record it, you can use data logger, sensors, okay, take a video recording. So all these are good suggestions, because it kind of directly talks about how to overcome that error. Okay, what is important is you're talking about how to overcome that particular error that you highlighted. Now, I repeat, the thing that I'm trying to tell you here is this. Whenever you answer question on limitations or errors, you have to think back about the experiment that is given to you. It cannot be just something that's right there up in your memory because you have gone through a few number of errors, limitations, and suggestions. Whatever you suggest, of course, it's good to go through a list of it, but it has to be based on the experiment given to you. Okay, it has to be really based on an experiment given to you. Yeah, yeah. Sorry, let me show you the answer again. Yeah. Okay, you can take a look at that. Yeah. All right. So, guys, okay. So just to give you an idea, just now I was telling you, right? Your paper consists of section A, like say for those students doing pure physics, right? Consists of section A, and section A has two questions. One could be something like the kind of question we just did. The second question, a lot of times will have the planning aspect to it. Will have the planning aspect to it. Now, it is the third question, right? Section B, which is the long question, which is 20 marks. Now, that section B question, right, is where like they will involve you coming up with a table, a full table, recording all the data and plotting a graph. Now, that whole series of question, which is your very next question here, right? Your very next question, can the source of error be the position of the possible position of the lock where you place the wooden rod? Mm, okay, but yeah, but the thing is that source of error is something which you can still control because that one is like if they ask you to put at 90 cm mark, you'll place it at the 90 cm mark, you see. But this one, this source of error, you can't really control. The other one, the source of error could be just like somebody makes that error, but chances are, but this error is something because of the nature of the experiment, you can't control it. There will always be bound to be significant effect on the timing. Okay. Yeah. Okay. Anyway, guys, like what I said, um, the next part, right? Instead of going through that long question, which is worth 20 marks, I am now going to question three. I'm going to go to the next question, which involves planning. Okay, for those students doing combined science, you may have a very short part of any planning question, but still you can follow this. But when it comes to the graph plotting, later teacher Benjamin will be going through question two, which involves the graph plotting. So that one, it's very important because that's going to be carrying the bulk of your marks. That will affect your marks for the like significantly. So that one we will do later. All right. So now I'm going to do the planning question. So everyone, move to question number three first. Yeah. Sorry. Yeah. This graph plotting. We will come to it later. Okay. This is the whole section. Can we now go to this planning and experiment? Okay. Okay. Now, guys, when it comes to planning an experiment, it's always typically you will have like section A will have question number two. That's where the planning comes in. Now, how many marks is the planning one? It's about 6 marks. This is 6 marks. Okay, it carries about 6 marks. Okay. Now, well, the question will ask you or will tell you what you need to do. You need to be very clear about what is the aim or purpose of the investigation. Because if your aim or purpose of the investigation, when you plan your experiment, is wrong, then whatever you write, it will be out of point. It's like asking you to write a essay or composition, right? And if you don't know if you get your title or you get the topic wrong, you can be writing a beautiful essay, okay, like 300 words or 500 words. It can be a beautiful essay. But if your topic and what you're writing is totally not related, out of topic, then you are off, right? Same thing here. If your aim or purpose of the investigation is not following what they want, then that is a problem. So you have to be very clear what they want you to do, right? That is important. So when you have your aim clear, that means you know what is the independent variable and what is the dependent variable. That means what you vary and what you measure. So what you change and what you measure. This has to be clear. Okay, you have to be clear about this. Okay. Now, when it comes to typical planning question, right? The first thing they will ask you to do is based on a given setup, they'll tell you what are the variables that need to be controlled. So what are the variables that need to be controlled? That means you keep it constant. Control means what are the other variables that you keep constant? Because it could affect the experiment. So you need to know this will be always, this is going to be your 1 mark already. This is definitely one of those things that they ask. What variables need to be controlled? Okay, and then you need to write down the clear steps, K of the experiment. You need to write down. A lot of times this will carry at least 2 marks, 2 to 3 marks, depending. This can be 2 marks or 3 marks, depending. Okay. And that's how it goes, right? 2 to 3 marks. The procedures include maybe you have to draw a diagram, but a lot of times nowadays they already have a diagram given in as part of the question. So you just have to say, set up the experiment as shown in the diagram uh, above or what. Okay. So if you already have a setup and diagram, you don't really need to do this unless you have to come up in an experiment from totally based on without a setup, then you have to draw a diagram and write down the apparatus. But other than that, this is just an indication. But what you're expected to do is to describe how the independent variable is to be varied. How do you change the independent variable? How are you going to change it? And how are you going to measure the independent and dependent variables? Okay. So this is important. How are you going to change the independent and dependent variables? Okay. And then, of course, okay, you already said here how the other variables are controlled. After you state what are the variables that you're controlled, then how are you? So when it comes to the procedures, right, how the other variables are controlled. Now, the next mark will be a description of how the data collected. How do you basically what is your table? How does your table look like? Or at least as the first row of the table, how does the first row of the table look like? And what graph could be plotted? This one is 1 mark. Okay, this is 1 mark. Okay, what graph could be plotted? And then a suggestion of relevant safety precautions for this investigation. So they will actually tell you. So this could be another 1 mark. So if you add it up, this will come to about 6 marks. Okay. So what we're going to do is we're going to look at this experiment itself. Okay, it's better to look at this. Okay, in this experiment, you will investigate the movement of, so you see, it's actually part of, normally the planning comes, okay, even those combined science students, right, you can follow this section here, right? Okay, so in this experiment, you will investigate the movement of a solid object through oil. Okay, an object through oil. So you are provided with a measuring cylinder containing cooking oil, a piece of blue tack attached to a string, stopwatch, a thermometer, and a 30 cm ruler, and paper towels. Okay, guys, this is a setup. Guys, these are actual O-level questions. These are real O-level questions. Okay, whatever you see here are really O-level questions from previously. Okay, look at part B here. This is your setup. So what they wanted you to do is to actually put a thermometer and measure the temperature of the oil. Now, let's say the temperature of the oil is around room temperature, around 25 point something. Now, thermometer, right? Again, the unit is degrees Celsius. Now, let's say your temperature is 27. Say, for example, your temperature is 27. Guys, you should record it to 27 for thermometer. It's to one decimal place. So you either record it to 0.0, or let's say it will jump in 0.0 or 0.5, right? So you can record it as 26.5. So these are all acceptable. So what is wrong is if you record it like that. If you just put 26, is wrong. Okay, you must have the 0.0. Okay, and if you don't have the units, so these are all factors or let's say your thermometer is to 0.0 or 0.5, then you cannot try to read in between. You cannot say 0.1, 0.2 if it's not to that accuracy. So here it jumps in 0.0 or 0.5 lah, in 0.5 degrees. Okay, anyway, let's come to the design itself. So place the piece of blue tack at the top of oil as shown. So what this experiment wants you to do is release the string. Observe the blue tack move through the oil and reach the bottom of the measuring cylinder. Use the string to gently pull out the piece of blue tack from oil and place it on the paper towel. So basically what you're doing is you release the blue tack and it falls through the oil, and you see the fall of the blue tack from the surface of the oil to the bottom of the measuring that cylinder lah, the jar. And then they say using the string, take it out and you put it on the paper towel to remove whatever oil that's stuck to it. Okay, now let's come to this is a typical question, guys. This is how your planning question will look like. Look at that now. So after you do that first part and all that, right? It is claimed that the time it takes for the blue tack of radius r to fall a distance d to the oil is given by this. So this is your equation. So the time it takes for the blue tack to fall a radius through a distance d, and for the blue tack of radius r is given by this. So now they say plan an experiment to investigate if the relationship is correct for the distance d, the blue tack falls through. So you want to check whether this thing is true, whether this equation is true, true for the blue tack when it falls through the distance d. Okay. So what they say is, in your experiment, the quantities that you keep constant, describe how you'll perform the experiment, sketch the graph. So you want to show whether this is true. Basically this. Okay, and explain one precaution. Guys, I want you to think about this. Think about this and just come up with, I'm going to give you about 5 minutes. I'm going to give you guys about 5 minutes to think about it. Now, while you do that, right, I just want to highlight the recent trend, right? Okay, guys, just very quickly, the recent trend is They don't just ask you to talk about the relationship with one quantity. Nowadays, if you go and look at the last few years of O-level questions, right? Instead of just one quantity, they just say if the relationship between the time that it falls and this, they just say whether this relationship is correct. So you may actually have a situation where you may need to investigate this and this. Look at that. You may have to investigate this and this. This is the recent trend. Okay, I repeat. So the recently they have actually made you plan your experiment such that you do one experiment based on D and one to investigate based on R. Okay, so keep that in mind. But anyway, for this question, since this only wants you to investigate based on D, you just focus on that and try thinking of that. Okay, we will discuss in another 3 minutes. Think about it. Okay, if it is in the middle of okay. So your question is if the thermometer reading, right? If your scale of the thermometer doesn't, it all depends on the thermometer, but most thermometers, right, they jump in zero 0.05. Okay, 0.05. Unless they give you a thermometer which can really read to zero point 0.1, then you record like that. But otherwise, most thermometers they jump in 0.5 degree. Hold on. Blue tag when repeating the experiment. Ensure that there is no oil on the blue tag. Yeah, yeah. That's yeah. Okay, guys. Try to answer this question. Think of the quantities that you'll keep constant and how you'll perform the experiment. This is quite an easy experiment. It's just that because you're going to vary the height, the you need to find that this is your basically the D is your independent variable, the one that you change, and T is the time, the one that you measure. This is the dependent variable. Yeah, if the temperature is in the middle of yeah, I think I answered you. Most of the time the reading is between it's the thermometer is actually given as 2.0 or 2.5. I mean jump in point 0.5. Okay, if it's really jumps in point 0.5, you record it to the nearest point 0.5 or point 0. But if your thermometer can read to point 0.1, then you can record in between. Yeah. Yeah, good, good. Jia, yeah. Okay, yeah, it's good that you all think about it. Get an idea. In the exam, right? Chances are you probably have to do this whole thing in about 10 to 15 minutes. Okay? Maybe not 10 to 15 minutes, but depending because section A, you have one question, you take about like the first question we did, maybe you take about 30 minutes. And then when it comes to this planning question, you probably come do the first part, and then you probably have about 15-20 minutes to do this. Okay. Like what I said, the current trend is right, guys. The current trend is they ask you to vary two quantities. They say check. Now, when you vary two quantities, listen, I want all of you to, okay, maybe I'll explain this later. What happens if they ask you to check whether the equation is valid for the two quantities? Yes, R must be controlled, you're right. But K, we don't know what it is, you see. K, K is an unknown, it's a constant. K is a constant. Yeah, okay. This question does not make it known, but where K is a constant lah. Okay, good that you highlighted it. K is a constant. You're right. The question did not specify, but K take it as K is a constant. Guys, can you write down K is a constant? Okay, Vera, is it acceptable to use meters? I think I answered that, right? Yeah. How about R? Yes, Kaden, yeah. Good question. Because in this case, R, because I just want you to very check for D. But in reality, if the question asks you to check the whole relationship, you have to also vary R. So, but when you vary one, you must keep the other constant. So you have to actually do the experiment such that when you vary D, you must keep R constant. And after that, you repeat it such that you vary R and then you keep D constant. Okay, I'm going to discuss the answer with you all. Okay, guys, basically, this is what it is. This is just to highlight, not to say you need to write all of this. This is just to tell you what you wanted. So the question wants you to investigate the time t, the blue tag falls through the oil through a distance d. This is just to highlight. This is like the aim lah. You don't really need to write it down. But what I'm saying is you need to be clear what they want you to do. Because you're trying to check this, you see, trying to check this. So D is the distance the blue tag falls through, and T is the time it falls through the oil. Okay, so your first mark comes here, control variables. So in this case, since they only wanted you to check, on D, right? So you keep the radius same. You can check whether the temperature of the oil, or you use the same type of oil. You can say using the same type of oil, same oil throughout the experiment, and making sure the shape of the blue tag does not change. Okay, can think of other control variables also. Like I think someone mentioned the speed at which you drop the blue tag. I think that's still valid. Yeah, the speed at which you drop the blue tag, I think is valid. Yeah, which is to actually drop it from the surface, from the edge lah. Okay. Depending on where you drop it, you can be falling through the same D, right? It can be, you see, your D is this, right? This is your D. But where you drop it, like if you keep dropping it, different positions, you see, this is another factor that can affect it. Where you drop it, okay, where position, where blue tag, position where the blue tag is dropped. Okay. Okay, look at that, guys. So basically, your steps are here. Set up the apparatus as shown. So in this case, there's already a apparatus. There's already a setup, right? So you can just repeat this line. If you have to follow the same apparatus, you can just follow this line. Okay, and then you can say set the 30 cm ruler, clamp to a retort stand. So basically, you use a 30 cm ruler, clamp to a retort stand with some marking. Okay, this is a marking. So you determine the position of the highest point of the oil and the lowest point of the oil. So where that means the bottom of the Almost the bottom of the cylinder lah. This is the bottom of the cylinder. So calculate the distance L by finding L1 minus L2. Release the string with the blue tag. So this is your steps. These are your important steps. Okay, this is going to carry now. This is going to be 1 mark. This one, like what I say, can be 2 to 3 marks. Because you're telling how you're going to measure the D. Okay, and then release the string and start the stopwatch. So you are talking about using the stopwatch to measure and you're talking about using the 30 cm ruler. This is the apparatus given. Okay, if the apparatus is not given, then you have to write down the correct apparatus. You cannot just say measure length, measure time without stating the instrument. Okay, you cannot say measure this and measure that without stating the instrument. You must talk about the apparatus or instrument. Stop timing once the blue tag hits the bottom of the cylinder. Record the time T and repeat to get another set of time T. Okay, guys. This basically your procedure lah. Okay, this is your procedure. So far, okay? Okay, let me see. Somebody asked a question. How about Kadir? Yeah, so R, yeah. So I hope answered that question, yeah. K and R must be controlled. Can we add in other constant variables like, yeah, temperature of the oil or type of oil? Yeah. You can, yeah, you're supposed to add constant variables like temperature of oil or type of oil. Yeah, Chung Fong, the purpose of this experiment, because they want you to check whether this thing is valid, you see. And they already said correct for the distance D. Check if this relationship is valid for this. So basically, that's why I said to check whether if K is constant, so the factors that affect it is D and R, right? So you want to check whether T is proportional to D. So they want you to check whether this relationship is correct for the distance D, the blue tag falls through. Yeah. So there will always be some equation given. So you have to vary it. They might actually give you something like that, y equals to mx plus c kind of thing. So you have to check whether it's valid in that sense. Right? So if you're asking what is the purpose of the experiment is to check whether this equation is valid. That's why you go and check the time taken, how the time varies according to the distance it falls through. Okay, so guys, this is the to get your other marks, right? So then they say pour out some oil carefully before from the measuring cylinder. You pour out some oil because you want to vary the D, right? Okay, don't forget, how do you vary the D? By pouring out some oil. Because if not, how do you vary the D? So then repeats steps. So this step is important because you must show how you vary the D. You cannot vary the D unless you take out some oil, right? Okay, and tabulate the data for D and values of T. Yeah, distance it falls through is the distance it falls in the oil. Yes, that's right. Correct. You're right. Okay. So after that, you tabulate this tabulate the values of D and T. So this is to show what you record here. Okay, this is what you record. Okay, then you can say that if you plot a graph of T against D, so you can actually show a sketch. This is a graph of T against D. A graph of T against D, you can show this. Okay, I didn't label this. T against D. If you expect it, if this is going to be proportional, you can show that a graph of T against D will look like this. So you draw a sketch, a graph. Okay, I want to highlight to all of you, right, is here we are only dealing with one variable, but the hold on, Sheikh, I'll show the first part. Yeah, maybe you all can take note of this first. Okay, and the precaution. What if I just release the ball from a shorter distance but same volume? Mm, Release the ball from a shorter distance but the same volume. Okay, the D is shorter distance means what? Okay, you see, because the D, if you go back to the question, it's about falling through this distance here, you see. We are not varying based on, so the starting position is always the surface. So you need to take out the oil to vary the distance through which it falls. So you can't, there's no other way but it must follow, it must, basically you have to remove the oil to vary the D. Okay. Yeah. So the precaution, right, guys? The precaution here is to ensure that the shape and radius of blue tack remains the same. This is one of the precautions. To ensure that the shape and the radius of blue tack remains the same after every drop. And repeat for more readings of T for smaller values of D to ensure values of T are reliable. So I'm just giving you two precautions. You can, as long as you write sensible precaution lah. So that's going to be another 1 mark. Okay, this is going to be 1 mark. So sketching a graph, 1 mark. Okay, the steps, the control variables, 1 mark. The precaution, 1 mark, depending on what the question wanted you to do. And then your procedure is about 2 to 3 marks. Now, like what I said, nowadays the trend is, I want you all to note, the trend now is they don't just ask about one variable. They may ask you to check whether this equation holds true for both. So what do I do if they do that? So in this case, right, what do I do if they ask you to check for both? Then you need to vary D and keep R constant. And then you just have to say, you don't need to write the entire thing. You said, I will do this experiment, but this time around, I vary the R, but I do it for one fixed value of D. Are you all listening? So if they ask you to if they ask you to check for two variables, then you write exactly what is written above. But after that, you mention that you repeat this experiment for one fixed value of D by changing R for for the blue tack of different radius. Yeah. Uh, okay, Vera, must we need to give a conclusion about a graph? Now, in this case, you don't need to give a conclusion. Later on, when you are actually plotting the actual graph, which teacher Benjamin will go through, you need to give a conclusion. Okay, and okay, somebody else asked a question. What question was that? Would the graph always be a straight line? Okay, in this case, this is a sketch because I'm basing it based on the projected equation. So I'm saying that the T against D will be a straight line because it's directly proportional, you see. The relationship is directly proportional. So you're suggesting that do we need W? Do we need to W? Okay, sorry, what's the question? Do we need W? What's that? Can you ask your Arabian, can you ask what do you mean by do we need to W? Do we need to describe? You don't really need to talk about the gradient. Yeah. In this case, the one you talk for the next part, which teacher Benjamin will go through. Okay, in case anyone has missed out this part, guys, you can take a screenshot. Okay. Okay, I just want to highlight the next part is important, is the probably the most important because this for pure physics students, this will be your section B question, which basically the graph, the table, all this is going to be carries the bulk of the 20 marks. Almost 10 to 12 marks is the section that teacher Benjamin will be going through. So I want you all to really know what it means. Now, a lot of times you can get a best fit straight line, but you can also get a best fit curve. I repeat, you can get a best fit straight line or a best fit curve. Now, a lot of the questions that a few of you asked about the straight line, conclusion about the line, all these will apply to the next part. Not for so much for the planning question. The planning question is just your prediction only. When do you know the line or graph start from? Now, in this case, yeah, I think all these will apply to the next question. Yeah. Yeah, you can see steps 8 to 9. Yeah. Okay, guys, those who missed out, you can take a screenshot of this. You can take a screenshot of this. Okay. Okay, let me give you 5 seconds. Those who need to take a screen grab, please do that. Okay. All right. Here you can take a picture of this also. Okay. Those of you who need to take a quick toilet break, yeah, you can take a quick 2 minutes toilet break. We are going to start on the next part. And like what I said, the next part is probably the most important section of it all. Okay, because it really is about the graph drawing. Okay, and it's important that you know how to do this. This applies to every student, pure physics and combined science. Combined science, a lot of times you will be given a straight line, but not necessarily. I think one of the years a curve also came up. So you must be ready to draw that. Okay. All right. Okay, guys, we are going to start the next part in another 1.5 minutes. Anyone needs me to show any other sections, let me know. Sorry. Okay. All right, guys. Okay, I'm going to pass this over to Teacher Benjamin.
Okay, thank you very much. Okay, give me a second. Let me just pull it up on my screen. All right. Let's see. All right. So I will be going through the graph plotting section with all of you today. Okay, now this part here is going to be pretty important, all right, as teacher Kadir mentioned just now, right? It's going to be very important, so please pay very close attention, okay? Now, when we do our graph plotting, remember that the graph plotting is always about studying the relationship between one quantity versus another, all right? And there are always going to be two quantities that we will talk about, which will be the independent variable and the dependent variable. Now, for your independent variable, all right, your independent variable will always be plotted on the x-axis, all right, which is going to be that horizontal axis. It will always be on the x-axis, all right, never ever on the y-axis, all right. And then the dependent variable, which is the one that you measure at the end of the day, that will be the one that you plot on the y-axis. Okay, so one of the mistakes that a lot of students make in the exams is that they will accidentally go and plot it the other way around. All right, never ever do that. Okay, it's always independent on x, dependent on y. Now, a few tips for when you draw your graph. All right, please remember to always choose a good scale. Okay, and to cover as much of the graph paper as possible. Okay, now I know that in schools, right, they tend to say try to cover at least 50% of the graph paper, but I would go even further and suggest that maybe you try to cover up to about 70 to 80% of the graph paper. You get the whole graph paper, use the whole graph paper. Okay, use it as much as you can, maximize that space. All right. Now, to the point where I would even recommend that if you realize your scale, right, if you've decided on your scale already and you realize that hey, actually the graph looks a little bit might benefit from me drawing on landscape, go ahead and draw in landscape. Right? You turn the graph to the side and draw the graph on landscape. It might actually do you some good. Okay, so don't be afraid to change the orientation of your graph paper where necessary. All right, now avoid using awkward scales. Now, what do we mean by a proper scale? Now, a good scale will be something along like 1, 2, 5, 10, right? Or like 0 0.1, 0 0.2, 0 0.5, 0. Or like 1.0, something like that. These are considered as good scales. Now, what would be awkward scales? Okay, awkward scales will be things like like in threes or in fours, right? That was, or like I've even seen one case before somebody draw in sevens. All right, that's absolutely terrible. All right, never ever draw with awkward scales, because when you do so, not only would you be punishing yourself, right? You would be making it very difficult for any sort of calculations and everything, right? And you will most definitely be marked down. All right, so try to avoid awkward scales. Usually 1, 5, 10 will be perfect, will be just nice. Okay, now remember that when you label your x's, label them as, for example, force, and then you slash Newton, right? So you are basically explaining to the examiner, like what is the unit that you are using, right? So like extension, then you slash centimeter. So you are explaining exactly what units you are using. Okay, now remember, always do your best to plot your points on the graph appropriately using small and sharp crosses. Okay, now when I say sharp, you can draw your sharp crosses by using a sharp pencil. Okay, so when you go for your exams, all right, please remember either to bring a mechanical pencil, or for those of you who are like me who prefer to use regular pencil, please remember to bring a sharpener just in case. Okay, and bring multiple sharp pencils. All right, sharpen them beforehand and bring them in. Okay, now for the rulers that you all have, right? Okay, please do your best to use your to get yourself a transparent ruler. Okay, either a regular transparent ruler, the straight ruler, or get one of those transparent curved rulers as well. Okay, for those of you who prefer to use the French curve, right? Yes, you can also bring those. Those are generally transparent, right? Those are okay. All right. So the reason why you want to use a transparent ruler of any kind is so that as you draw, you will also be able to see the plotted points. Okay, it is very, very important. It is very, very important that you are able to see the plotted points as you draw. Okay, so that's why I always use a transparent one. And as mentioned just now, use a sharp pencil whenever you draw the line or the curve. Now, for when you are determining your gradient, remember gradient, right? You want to demonstrate your gradient by using, okay, dotted lines all right, and you join them up to form a right angle triangle, as you can see in the diagram that I have drawn for you here. Okay, now your triangle should be more than half of the straight line. Okay, so try your best. Please avoid. Okay, avoid drawing a very tiny little triangle like that. Okay, that will be absolutely terrible. Okay, always try to cover as much space as you can. All right, draw for more than half of the straight line. Okay, and when you draw and you make your gradient coordinates, right, do not use the plotted points. Okay, make sure that they are individual lines or individual points on the line itself. Okay, do not use any of the points on the graph. Okay, is it required to have dotted lines for the gradient? The answer is yes. When you are demonstrating how you are finding the gradient, right? Yes, you must draw dotted lines to form the right angle triangle. Okay, this is for your working, right? Good question. All right. So with that, we now discuss this one here. Now remember, draw your dotted line, okay, to find the point on the y-axis and the x-axis, vice versa. That is for your gradient. Okay. Why can't use the plotted point? Good question. Now, because right, the plotted point in itself, right, is a part of your data. It's a part of your data. When you draw your best fit line, right, your best fit line may appear to be on the plotted point, all right? It may appear to be on the plotted point, but it may actually be skewed away from it a little bit. So for the sake of accuracy, right, we try our best never to use the plotted point, because then, right, if that's the case, right, if we can use the plotted point, let me show you, for example, if we can use the plotted point, right, then why do we even bother to draw the graph at all? Because you see, from the points that we have here, right, that we will plot our graph later on, right, you will realize, right, that if we can use the plotted point, right, then we can just find the gradient simply through using the calculations from the point itself here. Yeah, then it defeats the purpose of the graph already. So that's why we try to avoid the plotted points for accuracy and precision purposes. Okay, now for the next part here, right, if you draw your straight line, okay, generally speaking, for straight lines, you are trying to discuss the relationship between two variables, all right, between two variables here. Now, if you have, as you can see in blue color here that I have drawn for you, if you have a straight line, right, that is between two quantities, so say for example, f against x, all right, f against x, and you draw a best fit line, and the best fit line will pass through the point of origin. If it passes through the point of origin, then you can say that f and x are directly proportional. Now remember, when you use the term directly proportional, it must be for a graph where the line passes through the point of origin. It must pass through the point of origin. Then you can say directly proportional. Okay? In the event that you have a straight line graph where the line does not pass through the point of origin, right, you cannot use the word directly proportional, but you can say that f and x have, say for example, in this case here, a positive linear relationship. Okay, so remember, the term directly proportional can only be used for when you pass through the origin. All right, now if, say for example, you plot a graph, right, you plot a graph and you plot a graph of p against 1 over v, all right, as you can see in red color here, p against 1 over v, and you end up with a straight line, right? If you end up with a straight line, you will notice, right, that this here, you basically got something where you have p having a positive linear relationship with 1 over v, which translates to p being inversely proportional to v. Does that make sense? So P is proportional to V, therefore, sorry, P is proportional to 1 over V. So we say that P is inversely proportional to V. Okay, so please be very careful in your exams. Sometimes you may be tasked with plotting a graph of something against 1 over something. All right, when you experience 1 over something like this, you must be very, very careful. Normally, they want to discuss inverse proportional. Okay, inversely proportional. Okay, so these are just some tips, right, for you when you are drawing your graph. All right, just be very, very careful and mindful when you draw your graph. All right, So for inversely proportional, it has to pass through the point of origin. Good question. The answer is not necessary. Okay, it is not necessary because for an inverse proportional relationship, right, mathematically speaking, right, it does not necessarily have to pass through the point of origin. For it is only required for you to pass through the point of origin when you are talking about a graph where it is directly proportional. Yeah, but when for inversely proportional, right, don't have to pass through origin. Okay, that's a good question. Not necessary, don't have to. So even if it doesn't pass through the point of origin, right, you can still consider it as inversely proportional. So long as you can prove and draw a straight line between one variable and one over variable of another variable. Okay, then that one confirm will be inversely proportional. Doesn't have to be origin. Okay, good question. Now, for the next one, right, we are going to look at a question, okay, which is question number 2. All right, question number 2, I will be providing you with some of the values first, all right, because clearly we don't have the experiment on hand, right? So I will provide you some of the values. Later part, what I'm going to do, right, is that I'm going to give you guys some time to draw the graph on your own, and then we will discuss from there. Okay, so for this one here, all right, in this experiment, you will investigate the power dissipated by a lamp at different voltages. All right, so in this case here, they want you to connect, all right, to connect the crocodile clip, okay, H, okay, at L equals to 100 cm, which is the whole meter rule, the entire resistance wire, okay, and then you close the switch, and then they want you to measure and record the potential difference accordingly. All right, so the value I will provide for you here, okay, of course it's not fair because we don't have the experiment on hand, so please take down the value here. The value here is V will be 1.0 and I, which is the current, will be 0.14 ampere. Okay, I get you all to write this down first. Okay, now once you have written this one down, okay, basically now for the next part of the question, right, they want you to measure, right, for different values of L. So you started your L at 100 cm, you are going to close it down 100 cm, then after that 90 cm, 80 cm, and so on. All right, you're going to measure different values of your V and I, okay, based on the L value. Okay, so you change the L value and then you go from there. All right, so then every time, once you are done with all that already, you have to plot it down in a graph, right? You put it down in you put it down in a table first. Okay, so you complete the table as follows, right? So we have all of the values here, and I will provide all of the rest for you here. So as you can see, we can calculate R, right, using our formula of V equals to IR. So R equals to V over I. We can find all of our R values, and we can also find our P value, which is the power. Okay, and remember your power is always measured in watts. So using the formula of P equals to IV, you will be able to find all of the different values for P. Okay, so I'll get you to complete this table as well together with me. Okay, and this is where I want you guys to help me out as well. All right, I'll keep showing you all the table. Okay, but for the next part, this is where I want you guys to try on your own, which is I want you to, with the values that are given to you in this graph, in this table here, plot the graph for yourself. Okay, and see very carefully. See very carefully. Okay, the graph is P against L. Okay, P against L. All right, and in this question, they ask you to draw the curved line of best fit. So you see in this question, we are not doing a line of best fit, not a straight line. It is a curved line. So it is a little bit of a curved ball. Okay, pardon the pun. Okay, it is going to be a best fit curve. All right, so I get you guys to finish the table for me. Okay, and then I want you to try and plot the graph. And after you are done plotting the graph, also help me to find the tangent of the curve at L. Okay, at L equals to 60 centimeters. Okay, so I get you all to try this on your own first. I'll give you all sufficient time. Okay, maybe let's say we take about 5 minutes or so, all right, 5 or maybe about 7 minutes, right? Get you all to try this on your own first, all right? Please plot the graph, and then I will show you guys how to draw the graph, okay? Here's a bit of a hint from me as well, all right? Please remember, do not be afraid to draw in landscape, all right? That is my hint to you, okay? Don't be afraid to draw in landscape. All right, and please remember which one is the y-axis and which one is the x-axis. Okay, I'll give you some time to try on your own first. All right, any questions so far? Please feel free to put it in the chat so that I can help you all. Why is the SF for the last two values 3SF, but for the rest is 2SF? Um, Good question. So for this one, right, it is just dependent on what numbers you end up getting lah. So in this case here, right, by right, yes, you normally follow up to about you follow the lowest SF, right, which is 2SF. But because the value that you end up receiving, right, for like say for example in like for 20 and 10, right, you will get a value of around 10.9 something something, correct? Now, if you were to leave it at 2SF, right, you will end up with a value like, for example, 11, and then your this value will also be 11. It's a little bit weird, right? So therefore, for this case here, right, we will just leave it as 3SF. It's also completely okay. All right. Yeah, that's a good question. All right. So exercise discretion. Normally speaking, right, when you leave it in significant figures for your processed data, you can leave it in 3SF. But is 2SF okay? Okay, so if let's say for example for the last two, for example for your resistance, right? If you put your if you leave your answer in 2SF, right, your answer for 20 and 10 will be 11 and 11. So they will both share the same data. Yeah, so is it okay if you are not using it to plot your graph? I guess it's okay. I don't think you'll be penalized. But if you are, say, for example, using it to plot the data in the graph, like for example, in this case here, when you're using the power, then it will affect your graph. Then that is where you will confirm be penalized. So I would say it's generally okay, but for this case here, exercise discretion lah. You in this case here, you leave it at 3SF, it will give you a better number to work with, so that at least these two values here, the R and R here, right, these two values, they do not end up as being the same. Okay, yeah. SF rule not mandatory because my school is super strict about it. Okay. So this one, right? It really does depend. So generally speaking, at least at the O levels standard, right? At the O level standard, yes, you must be relatively strict when it comes to SF. So process data, all right, process data, you always follow the lower significant figure from the data itself. Okay, you always follow the lower significant data from the data itself. So that one remains true. All right, that one is very important. Okay, especially for this one here. So in terms of the power, right, as you can see, for all of the values of the power here, right, we chart all of them to 2SF. Because if we put 3SF, right, then we will be marked down for it. Okay, so yes, follow the SF rule. It is mandatory. Yeah. But in the case of this one here, right, the resistance one, this one is a little bit of a how to say exception lah. Okay, we seldom encounter something like this. Okay, you can leave it in 1SF, right? But it will yield values which will be a little bit unsightly lah, because they will end up as the same value, which we don't want. So in this case here, we exercise a little bit of discretion. But generally speaking, it should be just like how it is shown in the power section. This one here. Okay, all 2SF, 2SF, 2SF. Okay, yes. Follow your school's convention. That's the important thing. Good. Is it true that the cross must be smaller than the square? Good question. The general rule of thumb is try your best to, because you don't want the cross to interfere with the other squares when you are plotting the graph. So this one is more to being more about neat and tidy rather than a rule, rather than a rule. So it's not a rule that it must die be smaller than a square, not necessarily. But as far as possible, we try our best to make them small and neat so that it doesn't interfere with the rest of the graph that we draw. This is more for like just neatness lah in general. Okay, but it doesn't have to be super small, right? So long as it is concise enough that you can see and so that the examiner can see, can already. Okay. Okay, now, is everyone done? All right, so I am now going to go through the last part, all right, which is now I'm going to show you guys how your graph should be looking like, okay, for this kind of question. All right, so let me show you guys how we would do it. Now, remember what I told y'all as the hint from earlier on just now, right? The hint, just to clarify, R and P are both calculated value. Thus follows least SF, which is 2. Yes, correct. That's correct. Okay, which is 2SF. That's correct. Okay, so as I mentioned to you all just now, when we plot our graph, right, you see, this case here, this graph paper given to us is in portrait mode, right? It's in portrait mode. However, remember what I told y'all, do not be afraid to draw in landscape mode, because in this graph, right, it so happens that the scale, right, is designed in a way that it actually benefits landscape mode a little bit better. Okay, so this is how I would be drawing the graph. All right, this is how the graph should be drawn. Okay, now in this case here, you can see, right, that the graph, right, you plot all the graphs already, and then from there you draw the best fit curve. All right, the best fit curve. Now, as you can see, right, there will inevitably and unfortunately be certain points that are a little bit far away from the curve. Say, for example, like in this case here, you all see this point here, right? You all see this point here, all right? But you see, right, this point here is a little bit of an anomaly, right? It's a bit far away. Now, when you receive a graph, right, when you look at a graph, right, and you think about the general shape of the curve that you draw, sometimes there will be points that will be a little bit skewed, a little bit away. Now, what you can do for these kind of points, right, is that you go back to your experiment and you repeat again and see whether you can change the result and see whether you make a calculation error. But if there is no error, sometimes it is okay to have a point that is a little bit of an anomaly. Okay, sometimes it can be a little bit of an anomaly, and that is completely fine. Okay, so once you are done with that, you will draw a graph. Hold on. Do we have to choose whether we want to plot the graph in landscape or portrait, or do we have to follow as portrait? Not necessary. So you can choose to draw in landscape. You can choose either or. Whichever you think is better based on the table, right? You look at the table, right? And you from there, right, you think about the you think about how you're going to draw it, right? You think about the scale, right? And you decide there and then whether you think that portrait or landscape is better to draw. What can give the best spread and scale? Yes, correct. So teacher Kadir mentioned, right, based on what gives you the best spread and the best scale. Okay, so in this question here, right, specifically, we chose an example that looks best when you are able to draw it in landscape mode, as you can see here. Okay, and then from there, how you draw, right, you look for your gradient. Okay, you basically want to draw a straight line, okay, over at where L equals to 60 centimeters. Okay, and from there, you will do your dotted lines, okay, as such. Okay, find your XY values for individual points, like so, here and here. Okay, and then from there, you find your gradient. Okay, from there, you find your gradient. Okay, so in this case here, based on what I have, right, based on what I have, the calculation will be as follows. Okay, let me give you all some time. I'll give you all some time to take a screenshot of this, so that you all can use this for the working later on. Okay. Okay, give you all about a few seconds to take a screenshot here. When taking values from the graph, do you always record the precision to half of the smallest square? If not, when do you do it? From the graph, taking values from the graph. When you are taking values from the graph itself, right, you try your best not to take values from from half the smallest square. You only do half the smallest square when you are taking values from the table and you are putting it into the graph where it does not necessarily fit the scale of the smallest square. You do it only for when you are not able to fit it within the smallest square, then you take half of the smallest square. But when you are taking values from the graph that you have drawn, you avoid taking values at half the smallest square. Yeah, you avoid it. You try your best to always take it based on the scale, based on the smallest square. Yeah, so you only do half the smallest square when you are plotting the graph based on the data that is in the table. Okay, so guys, now that we have the graph already, all right, based on what we have already, right, we are going to calculate the gradient. Okay, so for your gradient, all right, you do your y1 minus y2 over x1 minus x2. Okay, and then you will get an answer here, which is negative. Okay, now don't be alarmed when you see your final answer. It must come up to negative, right? Because when you draw your gradient was downsloping, correct? So the gradient will come up to be negative. Now, one thing to be very, very wary of, right, is this, the units. Please remember that when you are plotting your graph and you are drawing the gradient, right, your units are very, very important. Your units in this case here will be the y unit slash the x unit. So in this case here, it's watts per cm. Okay, so the units is very important. Please do not forget your units for your gradient. Okay, now in this question, they also want you to explain the trend in your graph. So in this case here, to explain the trend, you can very simply say that as L increases, the length increases, the power P that is dissipated also it decreases. But because it is a curve, right? Because it is a curve, we say that it decreases at a decreasing rate. Okay, it decreases at a decreasing rate. So the reason why is because the current flowing through the bulb decreases, right? Because the longer the length, right? As the length increases, the more length means that there will be more resistance. More resistance means that there will be lesser current. And as the current decreases, we also noted that there would be a decrease in the voltage as well, right? There is a decrease in the voltage. So therefore, since P equals to IV, don't be afraid to use the formula in the answering itself, right? Because P equals to IV. So as the current drops, so does voltage. Therefore, the power will decrease. So that is why as L increases, power decreases. Now remember, please remember that we always discuss the independent variable first, then the dependent variable. So we never ever say, as the power decreases, L increases. No, never. Because L, the length here, is what we are changing. So we must say, as L increases, power decreases, not the other way around. Okay, other way around would be completely wrong already. Okay, so as L increases, the power P decreases as well. Okay, so this is how you draw your graph. Okay, so your graph, right, sometimes can be curved, sometimes can be straight line. Trust yourself as you do the question and as you plot your graph, right, as you plot your points, don't think like, oh, confirm must be a straight line, so it confirm must be a line of best fit. No, not necessarily. Okay, sometimes it can be a curve as well. So this one you have to exercise discretion. Okay. All right, so with that, we have come to the end of today's session, all right, because we will end today with the graph drawing. Okay, if there are any questions, please continue to post them in the chat so that we can have a look. Teacher Kadir, is there anything that we want to address to the students? Okay, the link to the worksheet is put up there already. Teacher Kadir has put the link there already. Okay.
Yeah. Okay, guys. I think you have been listening to teacher Benjamin, right? So I think it's important that you take note that the graph drawing, right, or the points mentioned here are all very important. Okay, especially the idea that you choose a proper scale. See, the choice of scale is important. Okay, the choice of scale, because that's one of the things. When you look at the data, right, you must know how. Now, I mean, like this particular question, right? I mean, you really have to deal with quite a lot of points to plot, lah. In reality, in the actual exam, you probably only have to plot about 5 or 6 points. Okay, but this is just exercise given so that you deal with that and you see by looking at the table, right? By looking at the table, you must know what is the best skill. Like just now, most of the time we'll be plotting the graph portrait if it allows it. Okay, but see in this particular question, to actually turn the graph and draw landscape was a better choice. Okay. Now remember, if you end up squeezing your graph too small, you can still have what you call a scale that is uh, like using an even scale. But if it kind of squeezes the whole graph into like you only use half the graph paper, then that means you did not plan it so well. So the whole idea is to have so that you can cover most of the graph paper. So you have to plan accordingly. All right. So that's important. So always have that skill of go and try out a few of the graphs that you have done before in your practical and see why you lost marks. Go and check why you lost marks. Probably after today's session, if you look through some of your practical worksheets, you are able to see why you lost marks. Okay, you totally understand it, and this will help you when you're preparing for your prelim practical, okay, physics practical, and also you aim to do better for this. Now, like what I said, the mental preparation going into practical is very important, and make good use of this the upcoming prelim to actually tune yourself correctly. Because once you go through this once, the entire thing, that is going to be like the main thing that will, when you go for O level, you feel a lot more relaxed and, uh, you know, you know you have done this and It's important that the prelim you actually go through the whole process. Okay, so think about all that stuff, right? Okay, so about reading off the graph for values, I mean, do you add a zero at the back if you're
Teacher
reading?
Kadir, hold on. Let me answer Cheong Fong first. So Cheong
Yeah,
Fong,
sure, sure.
this one here, right? Does the scale have to be on the edge of the graph paper? So what I've drawn for you here is the typical scales that we tend to use for the graph. Does it have to be on the edge of the graph paper? Not necessary. Okay, so it kind of depends. All right. Generally speaking, we try to put it along the edge. Okay, but that is because we are trying to maximize the space. Now, if you realize that, okay, maybe I need one square less, you can actually draw to be about one square less. Any less than this, like say for example, you go and draw like two squares less, three squares less into the graph, right? That's where your graph tends to start looking a little bit awkward already. So normally, right, when you are given the whole graph paper, you try to use the entire paper lah. So in this case here, right, as you can see, maybe these two that I've drawn for you are quite acceptable. The one that you have seen here, right, we use one edge, the bottom edge, and then we move one in towards the right hand side, right? This one is also quite acceptable, right? But if you go any deeper into that, right, into the graph paper, right, then it becomes a little bit awkward. So not so pleasant, not so pleasant. Okay. Then what about the 50% line thing? Okay. So the 50% line thing, right, that we mentioned just now is talking about the is talking about when you are looking for the gradient. So let's say, for example, right, uh, let me erase this first, okay. And let's say, for example, I draw a graph, okay, and say from here to here, okay, something like that. All right, I draw a graph, I draw a nice graph from here to here. Okay, now what do I mean by 50%? 50% means you use let me use my dotted lines, okay, we use more than 50% of the line, okay, when we are trying to find our gradient. Okay, we use more than 50% of the line when we are trying to find the gradient. Less than 50% will look something like this. And as you can see, right, it's super awkward, right? It's super awkward when you draw it like that, right? So we tend to avoid doing our dotted line and finding the gradient like this, okay? We try to use as much of the line as possible. That's what we mean by 50% of the line thing. Okay, sorry, Teacher Kadir, you can answer Faith now.
Yeah, yeah. So yeah, I think yeah, generally I think most of the questions are all answered already.
Oh, is it? Wait, hold on. Faith's one, what was Faith asking? About
I
reading
think
off the graph for values. I meant
uh
when do you need to add a
add a
zero
zero. I think it's
at
talking about the reading the smallest square lah.
oh uh when do you need to add a zero at the back of your reading to match the DP of
I think
the
the reading, right, because you are reading off the graph only for gradient values, right? I think you just read to half the scale is okay, right? You don't really need to add a zero if not necessary. You don't really need to do that.
Hmm.
And but the general point is you need to record to you can read to half the that of whatever scale you chose, right? Whatever scale that you are the one who's setting the scale, you see, guys. You are the one who determines how that scale will be. Okay. And then from there, your smallest square, right? You all know what's the small square. You can as the Benjamin teacher Benjamin is showing you the graph here. The small square, you can see what's the small square. As long as you read to half that small square, or even that small square, I think it's okay. Not very particular. Yeah. So as long as you are consistent, and that's fine. Now, most likely topics, right? As I said at the beginning, you can expect mechanics and electricity lah. That one is more or less a given. Okay. For pure physics, you can expect one mechanics and one electricity base. And the other one can be a mechanics, it can be a combination, or who knows, they might even give you a light based or even thermal physics question. Or it can have components of, like last time they actually have a beaker of water. You actually put like a thermal heater into it, right? And then so there are two parts to it. There's a bit of thermal physics as well as electricity, because you're using electrical circuit to heat up the water. So it can be a combination. So a little bit of that and little bit. So you can't really say which topic, but mostly you can expect mechanics and electricity based. Now, combined science students, again, yeah, lah, most likely it's either mechanics or electricity based. Yeah, but electricity based, right? Remember, it's one of the easiest to, if you actually follow the setup, it's very fast. You can take your readings very fast if you actually follow the diagram and whatever sequence, right? The instructions, you can actually set it up very quickly. Okay, I just want to highlight coming Friday, if you have not registered yet, the coming Friday is the chemistry practical series. Okay, again, do register for it and download your materials early so that you can benefit the best. Yeah, again, it applies to both pure chem students as well as the combined science students can also benefit from it. Okay, I hope you guys had a good session, some good discussions today, and then a lot of you did ask question. I hope it clarifies, and we wish you all the best. And guys, just to let you know, we will also be having the O level, how to prepare for O level physics next week. How to prepare for the O level physics. Okay, that's the O level. Okay, this Friday is the O level practical series for chemistry. Next week, Tuesday, we will have tips and strategies for to prepare for the O level physics paper itself. Okay, that's next Tuesday. So please do come and join that session, and we can also do quite a bit of good discussion there. Okay, and yeah. So otherwise, guys, all the best and have a good night. Thank you, everyone.